Okay, in this video we're going to take a look at the work kinetic energy theorem, which basically says that the change in kinetic energy of an object is equal to the net work done on the object. All right, so here's the problem. I have a skier at the top of a hill. The hill makes an angle of 9 degrees with the horizontal, and we're going to assume that there's no friction here. It's a frictionless surface. As the skier slides down the hill, I want to determine the work done by gravity, and then I want to use that to determine the velocity of the skier at the bottom of the hill. All right, so first off, the work done by gravity, we're going to do the dot product of the weight vector and the displacement. All right. One thing I left out of here is that this hill is 100 meters long. All right. So from top to bottom, the skier is going to travel 100 meters from the top of the hill to the bottom. Now, if we look at this, so for the dot product, W cross dot S. To find that dot product, we take the magnitude W, multiply it by the magnitude of S, times the cosine of the angle between them. So if we look at this, the skier is going to travel this way. The gravitational force is straight down. So this angle between the displacement vector and the weight vector is the same as this angle, 81 degrees. All right, so the work done by gravity would equal mg s cosine 81. All right, so the mass of the skier is 65 kilograms, g is 9.8 newtons per kilogram, times s times the cosine of 81. All right, now we already did this out, and I got 9,964.5 joules. All right, so you can multiply those out to verify that that's true. Now, I'm going to use this to determine the velocity of the skier at the bottom. Now, I know that the change in kinetic energy is caused by work done on the skier. Now, because this is a frictionless surface, the only force that's doing work is the gravitational force. So I know that 1/2 m Vf squared minus 1/2 m V0 squared equals 9,964.5 joules. Now, I didn't explicitly state it yet, but at the top, the starting velocity of the skier is 0. He starts from rest. So this whole term is 0, right? So I plug in 1/2 times my mass times Vf squared, set that equal to 9,964.5 joules, all right? Do some algebra, and I got Vf to be 17.5 meters per second. Okay, so we know that when the skier gets here, he's going to slide along that horizontal surface at 17.5 meters per second forever and ever until another force acts upon him. Now, up ahead, there's a rough patch, so there will be another force in the x direction. There's going to be some friction. So what we want to do is determine the work done by friction as he crosses through this rough patch. So the work done by friction will be the dot product of the frictional force and the displacement. So that's going to be the magnitude of the friction force times the magnitude of the displacement times the cosine of 180. All right, so in this rough patch, displacement is to the right the friction force is to the left. They make a 180-degree angle with each other. So the friction force is going to be mu times the normal force times the displacement times the cosine of 180. Okay, so if I plug in what I know, mu is 0.15. His mass is 65 kilograms. We're on Earth. Delta x, or s, is 14 meters. And the cosine of 180 is -1. I did this all out, and it comes to be out to be negative 1,338 joules. All right. Now, the last part of this question asks us to find his velocity at this point. All right. So again, we know that his change in kinetic energy from here to here is going to equal the work done by friction, because that's the only force doing work on him at that point. So 1/2 Vf squared minus 1/2 mv0 squared equals negative 1338 joules. All right. Now I'm going to add 1/2 mv0 squared to both sides. All right. I'm running out of room here, but if I plug in what I know, okay, I'm going to do 1/2 times his mass. Now, Vf at this point, we don't know. And in this problem, this 17.5 becomes V0. That's the velocity he has entering the rough patch. So V0, we said, was 17.5. 17.5 squared minus 1338 joules. Okay, and so I did all the math, and I got Vf is 16.3 meters per second, right? And you can do the math too to convince yourself that I did it correctly.